Welcome to the second video of Read with Atharva. In this video, we are going to look at React will be compiled, which is written by Brad Westfall on reacttraining.com. Actually, I got this article from a newsletter and we are going to have a read. And there's a lot of cool stuff here. It just goes into the very basics and it goes into things like useMemo, useCallback. So if you were like very afraid of touching them before, we will go very deep inside those and see how rerenders work and why React being compiled is related to all of that. So yeah, let's get started. So the title says React will be compiled. In some ways it always was, but now you can forget about memoization. So this right here is very quite confusing if you don't already know what the content of the article is. But yeah, in some ways it already always was. What it means that it converts your JSX to things that can be displayed on your browser. So it can be like HTML, but instead it has a lot of layers in between to do all of that stuff. So like it generates JavaScript that generates HTML. So yeah, so let's start reading. Yesterday, so when it was published on February 16th, so on February 15th, the React team made this blog post announcing what they have been working on React. Andrew Clark from React team gives us a nice breakdown of the changes. And this tweet, I saw this tweet before, and yeah, people are very excited about it. So useMemo, useCallback, and Memos are going to be replaced with React compiler. Forward ref is going to be replaced, like ref is going to be a prop. React.lazy, you are just going to React server component. Use context is going to be changed to use context. Oops, I didn't want to open the tweet, but anyways, just things like this, like context.provider is just changing to context. All like quality of life changes. This is the blog post which has been mentioned in this article. There are a lot of different things. The one thing which we are going to focus in that article is React compiler. I'm not going to read all of this, but there are a lot of different things you can check, like actions and stuff. So like if you are familiar with Next.js, you already know Next.js server actions. So they're trying to bring these actions on the client side as well. But anyways, so let's go ahead and say, so the author has made a correction. I previously stated that it would be v19 that would be compiled. The React team announced that the compiled React, and I assumed along with others that this meant v19. It appears that v19 will have lots of features mentioned in the post, but the compiled will be probably the following version. So yeah, it was a good disclaimer. So whatever the version, I hope this post helps anyone who feels confused about what it means for React to become compiled. And I was the same person, right? I saw Twitter and there was a lot of different buzz around React being compiled, and like I was like very scared to ask anyone. So I thought let's see like what's going on, and apparently one newsletter sent me this. So, and I just had a read before making this video, so I already know what's up. But as we read, everything will start making much more sense to you. I'll try to show examples and historical context for how we got to this point, because it has been a heavily discussed topic and sometimes hard to follow along, especially if you haven't seen the whole story of React play out. So yeah, we are going to be in a history lesson today, folks. So yeah, have your popcorn. As we continue, keep these React principles in mind that will not change when we compile React. So these three facts are going to stay the same. So the first one is React state is immutable. The second is UI is a function of state. Third is re-render when state changes to produce new UI. I think these are the very basics of React, and these are going to remain the same. Aside from the version numbers, I think React as having three distinct eras. The first one is a class components era with no primitive for abstraction. The hooks era, we need to memoize, and the compiled era, auto memoization. So most of you, like if you're a beginner, you might be from the hooks era, which is the current era which is going on. And I've been somewhere between the class components and the hooks era. Like when I was going into React, everyone was switching back to hooks, and there was a lot of thing about like how to convert class components into functional components. And yeah, that's when I started React, but mostly I had just developed using hooks. I have never worked with class components, but I do know how it works. So yeah, we are about to enter the compiled era. By the way, which era of React did you first code it? Let me know in the comment section. I'm very interested to know about it. We are about to enter the compiled era, but how did we get here? For those of us who created projects with class components, we remember the problems that classes gave us when we wanted to abstract and reuse our code. React was lacking a primitive for reusing the code, so the community invented patterns such as hooks and render props, which are less than ideal. So what the thing with primitive here is like there is no base for you to reuse code. So like you need to have a ton of workarounds to achieve that, and that it means like lack of primitive, which means that there is no default way of doing it. You need to do a lot of workaround to get to code reusability. It turns out the problem with making a primitive was that classes themselves didn't give us the level of composition we needed. So React team started looking away from classes and into functional composition, and that's how we got into functional component. At the time, functional component existed, but we called them stateless functional components because they couldn't have state or the lifecycle stuff that classes had, and I didn't know about this. This is pretty fun. The React team saw functional components as a way to give us the primitive we needed. If only they could figure out a way to let functional components hook into the life cycles of React, and that's how hook came. So yeah, that's the term hook came from. When hooks were announced in 2018, I was at the conference. The author was in the conference. I remember when Ryan Florence, I hope I'm pronouncing the name correct, went up to the talk right after the announcement and did a render props to hook refactor in front of everyone. We were floored. Hooks, and specifically custom hooks, were going to be primitive we were missing. What we didn't realize at the time was that commingling of all of our code into one function might provide us with composition, but would come as a trade-off because now we've had to memoize. We'll look at what memo is in just a bit, but just remember that when you are re-rendering, a lot of different stuff just gets reloaded and it's just a complete mess. And to prevent things from getting reloaded, you need to introduce memoization to cache the specific values. So yeah, we didn't realize that classes were innately shielding us from memoization given the nature of re-rendering. I think it should be re-rendering. Anyways, in class components, the render methods isolates its code from the other lifecycle methods. So like you used to have lifecycle methods in class-based component also. So like in functional based components, you have like use effect and stuff. So if I go on Google and search React class components lifecycle, no, this one is, I think, yeah, so maybe this one. Yeah, so there's a lot of things like component did mount is pretty much doing the work of use effect, but like with no dependency array. So if you want to just like have like when the component just renders, if you want this function to be executed, you can do that, and you can have like the conditions to check if you want to really do any changes or not. Yeah, and there are a lot of different things here. Render is actually a function that renders JSX, actually renders HTML to the browser. So all the JSX goes inside here, and that's what the article is saying, that render function is like different, is isolated from all the different methods, and that's just how classes work. It has nothing to do with like the functional structure, or like if the functional components are deliberately made to be manually memoized. So yeah, in class components, the render method isolates its code from other lifecycle methods, which in turn means a re-render won't adversely affect code that's not apart from the render phase. So if you do something and the entire component needs to re-render, all of the methods in the component will not re-render in the class-based component, but in functional-based component it can. So this was probably less of a design decision, as I said, and more of a characteristics of that's how classes work. This seems almost silly to bring it up at all, but it plays a role in evolutions that would come up next. Then we have memoized React. Class components were terrible, to be honest. I remember when we changed our 2-day workshop curriculum to hooks, and half of our topics were just evaporated because class components brought so much more complexity into apps that we didn't have to teach anymore. If we made a class-based component with a method to handle on submit, the method would never need to be memoized. Let's see what happens when we do something similar to function components. So we have a simple app component here. We have a state, we have an empty state, we have an on submit, and we are having an simple form with on submit inside the on submit handler. So like whenever someone submits the form, this function will be executed, and we just have the state to demonstrate. Like if we change the state, the component needs to re-render. So we are just showing what's happening here. So let's read through. Maybe you didn't notice it right away, but this function is going to recreate itself every time there is a re-render, meaning that there will be a whole new function in the memory. Usually not a problem that functions recreate themselves, and in this example it's not going to create any issues for us. It is worth noting that though this would not happen in classes, because it would have been a method separate from the render phase. So yeah, like if you do something, the entire thing needs to re-render, and even this function will be created again. And if this was a class-based component, that would not happen. Only the necessary things would be loaded back into the memory, and not the, like, for example, this function would not have been like created again. It's also worth noting that the general idea of things need to recreate themselves in JavaScript is not specific to React. I can show you my jQuery code from 2008 that could recreate functions and object also. I'm just joking. I have no idea where my 2008 code man. Anyways, now let's refactor the code a little. Now you have a form component. You might be thinking that unless like the on submit changes, there is no way the form changes, and if the form changes, there is no way the on submit changes, right? And that's why you probably have a different component, and you are passing in the function right here to handle things in a different kind of environment, try to isolate every single thing. It's still not a problem that on submit will be a new function on every render. The re-render of app will cause a re-render of form. So what will happen, like if this component re-renders, then this component will also re-render. Some will say that the component will get a re-render if the props change. That's not true. If form will get a re-render when the app gets a re-render regardless of props. So no matter what, if app gets re-render, the form will get re-render. So yeah, thanks for clearing it up. For now, it simply doesn't matter if on submit prop is changing or not. So you do see, right, like if you have a lot of different components here and you're just trying to isolate components into different components and just trying to make sure that unnecessary re-renders don't happen, it's really not helping, because if your main component is re-rendering, basically all of your components, all of your child components are also re-rendering. So now let's say we have some reason to prevent form from getting re-rendered when app gets a re-render. So this example is oversimplistic, but let's say we want to memoize form. So we use react.memo and we just memoize the form component. Now form will only re-render if its specific props change, not every time app re-renders. So only when on submit is changed, this component will re-render. But there's a problem. Yeah, now we have a problem. React heavily relies on strict equality checks to know if a variable changed, which is a fancy way of saying that they use triple equal to and object.is to compare old to the new. When you compare JavaScript primitives like string to each other using triple equal to, JS will compare them by values, and you already know that. So like if you do 4 is equal to 4, like if you check if 4 is equal to 4, it will work, it will say it's true. But when JS compares arrays, objects or functions to each other, the use of triple equal to is comparing their identity. In other words, their memory allocation. This is why empty object and empty object checking is false in JavaScript, because those are two different object identities in memory. So this object in memory is different from this object in memory. So the identities for these are very different, and that's why it gives false. And I want to do this right now in this video. Like I want to see. So I'm going to do console.log and I'm going to have 4 is equal to 4, and let's see. Yeah, it's true. Now let's do console.log and let's have an empty object here. False, even though it's literally an empty object, right? And it has absolutely nothing. So basically they should be equal, but they have different memory allocation, and that's why it's saying false. Let's do the same with arrays, and I'm going to have an empty array. Yeah, false. So the author is correct. Like for arrays, objects or functions, it's just checking it's comparing their identity and the memory allocation. That's why it shows false. Doing form is equal to react.memo. So like memoizing the component, it's saying hey React, we only want to re-render the form if the props do really change according to an identity change. So what we are doing here is like we are telling React if the identity of onSubmit changes, we want to re-render this component. And there is also another problem that comes here. So just like we saw, triple equal to just compares the identity. So in no circumstances onSubmit is equal to onSubmit. So the identity is always different, and your React memo won't even matter. So if your parent component changes, your onSubmit will get recreated, and onSubmit will be passed here, and it will see that onSubmit has changed, and it will just re-render the entire form component again. And this makes the memo here very useless. So yeah, this creates a problem because onSubmit changes every time app gets re-rendered. So yeah, just like I mentioned, onSubmit gets recreated. This will lead to form always getting a re-render, which means that memoization does nothing for us. It's a meaningless overhead for React at this point. Now we have to go back and ensure onSubmit does not change its identity when app re-renders. So we have this useCallback hook, and what does useCallback do? Mostly is like it takes a function and it tells React that don't recreate this function, make a cache of this, and then there's a dependency array. Like only if these value inside the dependency array is changed, then just recreate the function. So if you don't want a function to be recreated like 1,000 times, you can just have the useCallback hook, and you can just pass in a dependency array and tell React when you want to do that. So yeah. We use useCallback to stabilize the functions so its identity doesn't change. In a way, it's a type of memoization. In overly simplistic terms, memoization means to remember or cache the response of a function. It's like we are saying, hey React, this is a little confusing, alright? Hey React, remember the identity of this function I'm passing to useCallback, alright? When we get re-renders, I'm giving you a new function every time, but forget about that. Just give me the original function's identity from the first time I called you. So it's like caching, and like whenever the component is re-rendering, we are not creating a new function for onSubmit. We are just caching the old identity of that function. Memoizing the onSubmit function is usually not necessary, but it became necessary when form got memoized and received onSubmit as a prop. So we had this form memoized, and that's why we had to use useCallback to like make the memo have some meaning, right? Like if you didn't have it, it's just going to work like it's working right now. There was no point of adding memo, but if you added memo, you also need a useCallback to make sure your function is stabilized and it's not changing its identity that often. At React training, this is what we refer to as implementation bleeds. So yeah, I think what it means is that if you're implementing something, then you might need to implement something else into some other place to make it relevant, and that's exactly what's happening with useMemo and useCallback. So the problem doesn't stop here. Let's add more code. So then you have a state with empty state, then you have settings, which is just an object, then you have an onSubmit, which is a useCallback, and you have an empty dependency array, we are having an x variable which uses settings.x. So what's happening here is React is creating a cache of this function, and it's saying that x is equal to settings.x. So like whatever here inside is this probably some property. So it's just trying to show you, it's not like a very runnable code. It's just trying to show you the concept. So yeah, the settings object recreates itself on every render of app. So yeah, this is not an issue by itself, but if you know React well, you know that the linter will ask you to put settings in the dependency array of useCallback. So yeah, if you have used React, you might see like squiggly underline in below this brackets, and then it says that you need to add settings to the dependency array so that whenever settings change, your function is made again. So yeah. And what if you don't do that? Like if you don't pass in this thing, so the function will never change, the function identity will never change, and your child component will never re-render with like if it has memo, it will never re-render and you will never see the expected changes you want to see. The settings object recreates itself on every render of app. This is not an issue by itself. Oh yeah, we just read that. And now we have the settings object as usual, and we are accessing settings.x inside of the useCallback, and we are passing in settings in the dependency array. And if we do that, it's like we are saying we want onSubmit to be stable and not change on every render, but we do want to use callback to recreate onSubmit if any of the things in the dependency array change. So like if settings change by any chance, if we do anything that makes settings different, so like if I add settings.dark mode is equal to true, then it's changed, right? Then what useCallback will do is it detect this change and it will just go ahead and re-render the entire function. Not re-render, it will recreate the entire function. So yeah, and that also makes me think that the settings is like also an object, right? So like the first re-render and the second re-render objects will not be the same. So you might also be needing to memoize this. Let's read the article further. So you might ask yourself, why would I want onSubmit to change? I would agree with you. It probably doesn't need to change, but there are many situations in React where things like useCallback and useMemo do not need to re-memoize and create a new identity for the return value when the dependency array changes. They do need to rememoize and create a new identity for the return value when the dependency array changes. So like for example, where things need to be updated after like something is changed, that's when you would like to have it. The linter just doesn't know that we never want onSubmit to be different in this case. So yeah, you know better than linter, right? Keep in mind that linter is almost always right, but I handpicked this example to show you how we might not want what the linter wants. If we listen to the linter and we put settings in the dependency array, here is what will happen. When app re-renders, so we put settings inside the dependency array. When app re-renders, settings becomes a new object. Like I mentioned, settings becomes a new object and is not triple equal to the one with previous render. The dependency array sees settings as different according to triple equal to, even though its values haven't changed. The change in dependency array means that useCallback returns a new identity. The form gets re-rendered because of onSubmit changes. So it's like everything you did right now is completely useless if even one part is not memoized properly. What bleed thing it called it? Yeah, implementation bleed. So we have like useCallbacks, you have useMemos every single way, and just one place you don't have a useMemo and everything just gets redundant. So yeah, in short, forms memoization is useless. It will always get re-rendered when yeah, are we ever here? Yeah. So now we have more information, we have more implementation bleed because we need to memoize settings with useMemo so that we can keep the memoization of onSubmit intact. Let's take a step back to that question. Why would I want onSubmit to change? Couldn't we just disable the linter in that case? Sure, in case I think we can leave settings out of the dependency array, or we can just memoize it, which is what we should probably do. Or we could even argue that we don't need the memoized form in the first place, which would have prevented all this mess, which yeah, I agree. That's not the point, it's just an example. The point is that memoizing in React often leads to a cascade of implementation bleed. Like we just saw two examples and I just explained how one thing can lead to a butterfly effect. The topic of dependency arrays and why linter wants you to put things in them goes way beyond the scope of this post. I can probably talk about this topic for hours because it is vast with many nuances. The truth is the linter is usually right and has good intentions. The problem is a lot of React developers don't understand its reasoning and think the linter is just a small suggestion. In my experience, when you ignore the linter, you'll probably get bugs. So like I mentioned before, so like if you don't have an identity, so like if you change settings and if you don't have a new identity, then the child components won't recognize this function as a new function and they won't re-render. And yeah, you need to be knowing that what you are doing before not entering your things inside the dependency arrays. Here's a perfect example. Some years ago, I was talking to someone on Twitter and they said they never put functions inside the useEffect dependency array because it sometimes creates an infinite loop. Of course, because of the triple equal to thing. I said something like, why don't you use useCallback on those functions? And that would prevent the loop. And the problem is that the function is changing too often. They said, what's useCallback? And this is the common that people don't understand memoization or React well enough and then get frustrated with the linter. So I think useMemo and useCallback should be more common, and I think tutorial should be focusing a lot more on them as well, apart from use state and use effect. But yeah, let's see how the React compiler thing works, because it auto memoizes stuff. So depending on the performance and depending on how accurate it is, I think yeah, we still might need to do manual memoization. If you have worked with React enough, you know it can be a pain to deal with dependency arrays. Yeah, the linter might tell you to put stuff in the array and you don't like the outcome, like a loop. It's easy to get mad at the linter, but the linter was right. Not because React wants an infinite loop, of course, but you need to also memoize something now. So like, just like adding more work towards you. Dependency arrays are a way to deal with the fact that all of our code is co-located into a functional component that re-renders, and we want to monitor changes to variables over time. So yeah, we are going back to the functional component thing, that it's all being caused because we are using a functional component. Sometimes we end up putting objects, arrays, and functions inside the dependency array, and so make sure that you stabilize them with memoization. The way I explain what React means by stable is a variable that doesn't change unless you want it to. Let's look at this example. So you have a misc state, you have a dark mode state, which is false by default, and you have an options object with dark mode inside it. And yeah, you are rendering a user component with passing in the options, and you are using an use effect and just getting the user, just taking the options and stuff. So basically this options is being used a lot of different places, and it has only one property, which is dark mode, which is actually a state. We can see that when misc state in app changes, the cascading sequence is that the options will change, and therefore the use effect will run again, even though the effect has nothing to do with the misc state. Yep. So you better wrap that options variable in a useMemo. When you do, the linter will rightfully ask you to put dark mode inside the dependency array. So you use options, useMemo, and you return an object with the dark mode. So like, it's basically options is equal to thing, but you're using a memo. This is a callback function. You use a callback function so that you want to return some data. So you're just returning this, and we are passing dark mode in the dependency array so that it linter suggests this, because like, what would happen if you change the state, this value won't be changed if you don't add it in the dependency array, and this would cause side effects. So by doing so, we are saying we want options to be stable until dark mode changes. Exactly. Then restabilize it into a new identity, but don't do anything when misc state changes, because it's not in our array. We don't depend on it. Okay, I hope you are get the point that React depends on memoization. You have to write it yourself. You better get it correct, or you will have bugs or performance issue. Yep. Now we get into compile stuff. Depending on your definition of the term, you could argue that React has always had a compile step. JSX, to me, it seems like it's a loose term in JavaScript that basically means that the code you write is different than the code runs in the browser. So yeah, so if you write code that is different and the code that runs different, that's basically a compilation step. My first experience doing React was in 2015. Babel and React were still fairly new to most devs. In a way, their popularity grew in tandem with each other. React is famously known for compiling JSX to function calls. So I guess React is technically compiled, but I've always felt like it was a small syntax sugar, and semantics of one of the JSX element becoming very predictable functions means to me that it's a light amount of compiling. Today, we also compile TypeScript into JavaScript, of course, which to me is funny, because in this case, it just means that the TS we write evaporates when we save, and all the code that left is JavaScript. Yeah, that hurts. But I guess it still meets the definition of is what you write, what you get. Yeah. Compiling is a spectrum. To me, it feels like the compiled frameworks sit on a spectrum where some are little compiled and some are a lot. So like React 18 here is slightly towards not compiled, and React 19 is going somewhat here, but he then clarified that the compile thing is not happening in React 19. So we cannot just put it right there just yet. After the compiler thing happens, we might have the React 19 at this spot. Yeah, React feels like it sits on the not very much side of compared to the other modern JS frameworks. For me, what you see is what you get rule will determine where you are on the spectrum. JS6 means that React is somewhat compiled, but the other code I write is not compiled by React at all. By contrast, Svelte is so heavily compiled that the creator has described this as not even being JavaScript anymore. If you use Svelte, I personally don't use Svelte a lot. Like, I don't think I have ever used it. If you want a tutorial, make sure you leave that in the comment below. But yeah, I have heard things, and it's pretty accurate. That Svelte is really more of a programming language because the semantics of what you write are far from the semantics of what you get when it turns into JavaScript. So recently there was a lot of buzz around Svelte states, and it didn't look quite like JavaScript. I might be wrong here, but I think this is what the author means. Like, if you're writing something which is not your target code, then you are using a compiled framework. So yeah, I'm not trying to make this a comparison post or to say one is better than the other or that compiling is good or bad. I'm simply saying that it feels like a spectrum where different JavaScript frameworks either compile less, compile more, or compile to a point that they are not even JS anymore. The announcement from React team is that React is going to be more compiled than it was before. Will it mean that it will be more than some of the others? I'm not sure. It doesn't really matter where it ends up in the spectrum to me. What matters is why it's compiling. The answer is different reasons than the others. So like, I don't think React forget. I think it's called the compiler. They dropped the forget part of it. So I think the React compiler is not open sourced yet. I might be wrong. So we don't have much information of what it does, but there's a brief idea. React is not going away from immutability and towards observability. It will still have identity checks and dependency arrays. So the fact that it's compiled now doesn't make React feel similar to the others. It's going to be compiled so that we have auto memoization, so you don't need to use useMemo and stuff anymore. React is same as it's been for years without the downsides of manual memoization, which was one of the main issues with hooks and functional components. Personally, I am accustomed to my logic above JSX being left untouched. The change will mostly be unlearning how to think in terms of manual memoization. I agree. I'll have to trust the compiler to make good decisions for me, and I'm uncertain on how much of this I will have to guide the compiler to versus it just works. I'm optimistic and interested to play with it. Again, we do not know a lot more about like how it works. I don't think anybody other than the React team is trying it out right now. I'm like, it's live on Instagram code base. Like, the entire Instagram code base is being compiled using React compiler, but that's it. We don't know a lot more about it. In summary, it's worth noting that this idea just didn't spring up out of nowhere. We're talking about this as a possibility in React for 3 years. In Xuan Huang, I'm sorry if I pronounce your name wrong, introduced the idea of React Conf in 2021. I believe this was the React Forget conference. There's also been times where it was the hot topic on Twitter in the React circles for a few years now. Yep. My hope is that if you haven't been aware of these conversations, that this provides fair examples and context as to how we got to this point. Thanks for reading. When I read this article for the first time, it really struck my head hard that once you get into the React memo rabbit hole, you have to go all in, or like there is no way out. It's just like go all in or don't even do it. And the drawback of not doing it is like the performance drawbacks. And I think React compiler would do a lot of things. So like, I think for beginners it's going to be very good. React compiler will auto memoize things, and the people who don't really care about like hardcore development, so they don't necessarily want to learn about hooks like useMemo or useCallback. They just want to build their own thing and just want to exit out of React. I think this will be best for them. I think like this is a pure speculation. I don't know how good that compiler is, but like I think manual memoizations will still be required, and I can still think of the side effect that if React compiler is using auto memoization, we might be forced to use manual memoization. Like, if we have been avoiding it for now, it might be a thing that we might need to manually memoize. As per the article, like if you get into the rabbit hole, you have to go through the end. So might be, I'm not sure how it works. So like if you don't manually memoize it, you probably should not. Like, let's see how it works, and only then we can talk about it. But yeah, whenever it comes out, it will be on my channel, so make sure you click the subscribe button. And yeah, I don't think it will be anytime soon though, but yeah, you can always expect me to post about it on my channel. So yeah, that's it for the episode 2 of Read with Atharva. If you like this video, make sure you click the like button, hit the subscribe button, and make sure you share this video with your friends. I know this is a very long video, but yeah, I just like to make long videos and in-depth reads and giving my opinion about things. So yeah, if you have any suggestions about any type of content, if you want me to create bigger builds, just let me know in the comments below. If you want web3 content, just let me know. So yeah, that's it for this video. I'll see you guys in the next one. Bye.